Hey, it's Wednesday, you Bellringer nutcases. I know you guys love the Bellringer and class in general. Why not? But only a few days left. I mean, we are getting into the hot and heavy part of the year where, no, literally, it's going to be hot today and the air's going to feel heavy. And we're studying ecology, and we've spent the last couple of days on symbiotic relationships, right? And today I'm have you going to delve into a little bit about nutrient cycles. And so I'm going to talk a little bit about them in my Bellringer. You'll watch a little video on them. And then, of course, there's a worksheet about nutrient cycles. And there's different soil nutrients and that kind of thing. Now, you notice I'm not here today, right? I knew I had to be out, so I pre-recorded this. And but you know the routine. It's the same 3 things every day, right? That's how my routine is. 3 things: Bellringer, Ed puzzle, and then some kind of like notes or worksheet or something we do something, or maybe just me lecturing, right? Those are the 3 things I do every day. And it's like you get credit for each of those 3 things you do every day. So it behooves you to do all 3 things. Hey, a little reminder, tomorrow frogs are due, frog lab. After the frog lab, there's only a couple of labs left. So some of you are in desperate need of lab credits. So make sure you take care of yourself. And then, yeah, we're only a few weeks to the Regents. Woo! All right, enjoy the rest of your day. Enjoy this Bellringer.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
We talk about ecology, we would be remiss if we didn't talk about nutrient cycles. And in particular, I'm just going to talk about 2 nutrients or 2 elements that cycle and recycle through the environment, right? And so the first one is going to be the carbon cycle, right? Carbon is an element, right? And it cycles through the environment by changing shapes, or not by changing shapes, but by joining and unjoining various compounds that have carbon in them, right? We know that the primary place we find carbon is in the atmosphere in the form of carbon dioxide gas, right? Carbon dioxide gas, where does that come from? It comes from fossil fuel emissions, it comes from respiration, it comes from plant respiration, it comes from off-gassing of dead and decaying organisms. All that stuff piles carbon dioxide into the atmosphere. Carbon dioxide, we know, is a greenhouse gas. That is, it tends to help to trap heat coming from the sun in the atmosphere. Right? Luckily, we have some carbon sinks. The main carbon sink is plants doing photosynthesis. Plants capture carbon dioxide, right, out of the air. They capture that and they convert it to glucose. So we say that plants, trees, and algae and grasses and all that stuff, those are carbon sinks. The ocean is actually another big carbon sink. So carbon dissolves from the atmosphere into the ocean to make carbonic acid, right? Carbonic acid then gets floats around in the ocean and sometimes gets used up to make various things like calcium carbonate, like seashells and stuff like that. Okay, but yeah, carbon cycle. So the carbon comes from either combustion or respiration. And the carbon goes back into the cycle through photosynthesis. You remember respiration, right? Respiration is where you take glucose and you break it into pieces, and when you're done, you release ATP molecules, right? Unfortunately, one of the byproducts of doing respiration is you release carbon dioxide molecules. You take the carbons that were in glucose and you rearrange them into carbon dioxide molecules and you let them go, creating a greenhouse gas, carbon dioxide. Sort of the opposite reaction photosynthesis captures the carbon that's released through respiration, right? It captures it from the air. Remember that photosynthesis has two parts, the light reaction and the dark reaction. The light dependent and light independent reaction. We studied photosynthesis at length, right? In the light dependent reaction, water is absorbed and broken into H's and O's by sunlight. The O's are stripped away into the atmosphere, and the H's move over to what's called the Calvin cycle. During the Calvin cycle, or the citric acid cycle, carbons and oxygens from carbon dioxide have electrons added to them until you finally wind up with this big molecule of glucose. All right, so the carbon cycle, the carbon-oxygen cycle, right, is respiration and combustion releases carbon dioxide, carbon into the atmosphere. Photosynthesis captures it, right? Released, captured, released, captured. It's constantly being cycled through the atmosphere. What we worry about is things like deforestation, where we lose large amounts of forest, or if we lose large tracts of algae and stuff like that in the ocean, there'd be less carbon absorbed from the atmosphere. All right. Of course, carbon is also sometimes trapped deep down as fossil fuels and fossils, right? And of course, what happens if those are released, because those are dug up and then turned into fossil fuels, we just take that carbon and put it back into the atmosphere. The next nutrient is nitrogen. Now, nitrogen is also found in the atmosphere. Nitrogen is the most abundant element in the atmosphere. It exists as nitrogen gas, which is a nice inert gas, right? And of course, nitrogen is important because we need nitrogen to make proteins, right? So nitrogen gets cycled between the atmosphere and living things through the nitrification and ammonification of proteins, right? So like, here's nitrogen, right? Let's see, we'll start with nitrogen in the atmosphere. It gets captured by bacteria in the ground, right, and turned to ammonia, NH3, and then that gets nitrified into nitrite, right, and assimilated into plants, so that plants can then use those to make amino acids, and then you take amino acids and you turn them into proteins. Right, so plants make amino acids for us. They make it by taking nitrogen out of the soil, right? Of course, when animals eat plants, part of what they eat are proteins, so they get the nitrogen, and when they digest nitrogen, so they use a lot of it to make their own proteins, but any leftovers are released as ammonia, right? Which then have to be fixed again by the soil. Okay, so you can see the nitrogen cycle, right? It cycles from atmospheric free nitrogen that has to be fixed by soil bacteria into usable nitrogen. Nitrogen cycle. Remember, plants use nitrogen to make amino acids. There are 20 of them that were common to life here on Earth, right? They come in different varieties, but they all have nitrogen in them. And then, of course, once you have amino acids, you remember, after you do transcription in the nucleus, you can take those amino acids and piece them together to make proteins, translation, right? And then that's how you make proteins. So it's important to cycle nitrogen through the ecosystem so that organisms can make proteins. So that's just a couple of the cycles of nutrient cycles that you'll be studying today. Carbon cycle, nitrogen cycle. Water also cycles through. You'll learn that more about that. You probably learned that in elementary school, the water cycle. You'll learn more about that in earth science too. But yeah, so today, after this bell ringer, what you need to do is the Edpuzzle video about nutrient cycles, and then the notes about soil nutrients, where you'll study a few different soil nutrients that also have to be cycled through the ecosystem. And then I'll see you tomorrow, Thursday, for Hockey Jersey Thursday, right? You guys wear blue and white because it's Spirit Day. All right, see ya.